Mercury is notoriously difficult to observe from Earth. It sits locked deep inside the gravitational well of the solar system, perpetually hidden in the intense glare of the sun. Getting a probe there required a groundbreaking gravity assist maneuver, bouncing off Venus to slow down enough to fall toward Mercury. In 1974, the Mariner 10 mission finally achieved it. This chart shows the telemetry from Mariner 10's far ultraviolet spectrometer. The instrument returned a flat, baseline reading for millions of miles. But on March 27th, just 2 days before the probe's closest approach to the planet, the data erupts into a massive spike of extreme radiation. Out in the vacuum of deep space, a single anomalous data point forces mission controllers to question their basic assumptions about the target they spent years trying to reach. The team quickly formulated a hypothesis. The highly localized ultraviolet spike strongly suggested that Mariner 10 had flown past a dense, undetected object, a moon orbiting Mercury. Orbital mechanics dictate that this should be impossible. Mercury is so close to the Sun that the immense solar gravity would destabilize the orbit of any small natural satellite, eventually stripping it away or pulling it down to crash into the planet. The press immediately caught wind of the anomaly, and researchers spent days poring over analog printouts, captivated by the prospect of a satellite that defied the laws of physics. If a moon couldn't survive in that orbit, what exactly was blasting the spacecraft's sensors with extreme radiation? At the time, Mariner 10 was the only source of data in the entire environment. Without a second perspective to provide context, the mission team was left to interpret the signal based on the only celestial bodies they expected to see, proving that even the most precise instruments are limited by the observer's frame of reference. Astronomers on Earth scramble to point ground-based telescopes toward Mercury, attempting to lock on to the anomaly and verify the satellite. They quickly realized the ultraviolet source was not orbiting Mercury at all. It was a geometric illusion. Because of Mariner 10's trajectory, the spectrometer was looking directly past the edge of the planet, straight into the deep galaxy. At the exact end of that sightline was the star 31 Crateris, 1,930 light-years away in the constellation Corvus. The researchers thought they were probing our local solar neighborhood, but they had accidentally peered straight through it. A massive phenomenon in deep space had perfectly masqueraded as a local anomaly. To understand how a star nearly 2,000 light-years away could trigger sensors calibrated for a nearby planet, we have to look at the extreme physics of 31 Crateris. 31 Crateris is an ellipsoidal variable, a tightly packed binary system consisting of 2 stars locked in a close mutual orbit. The unseen companion's gravity is so intense it literally stretches the primary blue star into a distinct egg-like shape. Rotating synchronously every 1.48 days, this massive asymmetrical body spins chaotically, pumping out an enormous excess of extreme ultraviolet radiation. The violence of this binary interaction generated a signal powerful enough to pierce the interstellar medium and wash over humanity's first probe to Mercury. With the true source identified, the idea of a Mercurian moon was dismissed, relegated to a brief optical illusion in astronomical history. Mariner 10 quickly course-corrected and executed its primary mission. The probe mapped nearly half of Mercury's cratered surface and discovered the planet's global magnetic field. The incident pulled 31 Crateris out of obscurity, allowing astronomers to use its ultraviolet excess to study how stellar atmospheres behave when subjected to extreme tidal forces. Science rarely travels in a straight line. Often, a failed planetary discovery provides the exact coordinates required to study a much larger phenomenon hidden in the background of the universe.